So previously we were looking at similarity in any type of triangles. It could be acute, obtuse, isosceles, scalene, whatever. Today we're going to focus on specifically right triangles, and they're going to be similar right triangles that are actually falling inside of one another. So there should be a right angle box here. I don't know if there is on your paper, but there should be. Use the triangle to answer the following questions. What would the measure of angle B have to be? Luke? 50. Triangle sum. And I think, does your paper also have the right angles drawn here? What is CD? What is segment CD in the picture? Is that a mid-segment, an angle bisector, a perpendicular bisector, an altitude, a median? Not necessarily. We don't know these are congruent. If we knew they were congruent, then we would know. Perpendicular bisector, remember, did two things. Joseph? Again, we don't know it's a midpoint. It looks like it's in the middle, perhaps. Actually, it looks a little bit more skewed towards B than it does A, but to me. But we don't know it's a midpoint. Marquise? Nope. If we can figure out that it's not an angle bisector, right? If this is a triangle here, 40, 90, this would have to be 50. And then this would have to be 40. So that's not cutting the angle in half. What connects a vertex to the opposite side, or an extension of the opposite side, that is perpendicular? Not a median. It's not an angle bisector. Let's go back in our chapter 5 notes. Joseph. An altitude. Yes. If you remember, there are 3 altitudes that can be drawn in any shape. Sometimes we had those weird altitudes that would fall outside of the shape, like the little dashed line, we had to extend it. But technically, CD is an altitude. AC is also an altitude, because it's a side of, but it's also perpendicular, and CB. Are also altitudes. So you have 3 of them. In a right triangle, 2 of them are actually legs of the triangle. Now, what they want us to do is draw and name 2 smaller right triangles that are formed inside, and explain how we can prove that they are similar. And I'm going to suggest that we redraw them so that it goes 40, 90, 50, and that way it kind of makes sense logically. So let's look at this triangle. Again, since this one has the 40, 90, 50, I'm going to redraw this one so it has the 40, 90, and the 50. And so in this pink triangle, the 40-degree angle is A, the 90-degree angle would be D, and the 50-degree angle would be C. And then I'm also going to redraw the other small right triangle, this one. Again, whenever I redraw it over here, just so the corresponding parts are in the same location, I'm going to redraw it in the same manner. So the 40-degree angle in the green triangle is actually C, D, and B. Why are all 3 of these similar? Are they similar by which postulate that we learned?
Angle.
Good. They are similar by angle postulate. We don't know any sides, so it can't be SSS and it can't be SAS. It has to be AA. Technically, it's AAA. So we have all 3 angles, but it'd be your AA postulate. Now, we're going to learn about something called the geometric mean today, which deals with the altitudes. And it's going to be a shortcut to set up the proportions so that every time I give you a problem, you don't have to redraw all 3 triangles. Also, sometimes you won't know the angle measurement, so it'll make it even harder to see, like, oh, well, what side corresponds to what? Obviously, now I can see that AC would correspond to AD in this triangle, or AD would correspond to CD. But when the pictures are overlapping like this, it can be kind of confusing to see what corresponds to what. So we're going to talk about the geometric mean below. So reminder, the 3 ways that we know to prove triangles similar are angle-angle similarity, side-angle-side, and side-side-side. All right, so theorem 8.3, again, the numbers do not matter, tells us that the altitude to the hypotenuse of a right triangle, so the altitude to the hypotenuse, which would be CD, divides the triangle into 2 triangles that are similar, which we just proved in the warm-up. They're similar to the original triangle, and they're similar to each other. The similarity statement would be just like we had above. Triangle ABC is similar to CBD, which is similar to ACD. And actually this one, yeah, it does have the same letters, it just looks, it's tilted a little differently than the top one. And again, you can see how it's kind of hard to see, like, well, what would correspond to what when you don't have the angles to indicate, like, what's 50, what's 40, and so on and so forth. So that's why we're going to talk about this geometric mean that'll help us set up proportions a little bit easier. So the geometric mean is a proportion where the means are equal. And this was something that we looked at whenever we defined what a proportion was. We called, like, the 2 opposite corners the means, and the 2 other opposite corners were called the extremes. So here are some examples. We have A over X equals X over B. So in this instance, these are representing the means. These are representing the extremes. And they're telling you that these have to be the same. That's why it's X and X. Now, X is going to be the altitude of the triangle, aka the geometric mean. Remember that an altitude will touch a vertex and be perpendicular to the other side. So there's 3 cases where we will see the geometric mean, because we have 3 altitudes. The altitude can either go through the middle of the triangle, or it can be one of the legs of the triangle. So I have 3 scenarios at the bottom. If you're someone who likes color, you may want to grab your highlighters or pens or something, because I'm going to use color on the board, and it's kind of easier to see in your notes if you use color. But so when I talk about the geometric mean problems, again, instead of having to redraw all 3 triangles separately and look what corresponds to what, we will set up our proportion using the geometric mean. Now, I will refer to these as slots 1, 2, 3, and 4, like in the proportion. So we have a proportion equal to a proportion. The geometric mean always has to go in 2 of the opposite spots. I always put them in 2 and 3, but you could put them in 1 and 4 if you really wanted to, because we know cross multiplying will get you the same thing. So when you're doing these in slots 2 and 3, you're always going to put what the geometric mean is. Again, the geometric mean is your altitude. So in this instance, X is the altitude that I'm going to look at. X is also my geometric mean. So X would go in slots 2 and 3. The altitude or the geometric mean goes in those 2 slots. Now what goes in the other 2 slots are the other segments that would be in triangles that contain this side. So the only 2 triangles that contain this side would be this one. And let me go ahead and highlight this in a different color. And the other triangle that would have the green side as a side of the triangle would be this one. So what goes in the other 2 slots are the other 2 corresponding sides. So this would be A, and this would be B. Okay, so if the altitude's going through the middle, it is slicing it into two similar triangles that are next to each other. Now, when the altitude or the geometric mean is actually a side. Okay, so this time, this is my altitude, or my geometric mean. It will go in again slots 2 and 3. Whatever the altitude is, goes in slots 2 and 3. The means are equal. Now, to figure out what goes in the other slots, it's not necessarily A and B this time. You have to think about what triangles would touch that green side. So, obviously, this small triangle would touch the green side. So one of my corresponding sides will be A. The other triangle that would touch the green side would be not this one, because it doesn't touch it the whole side, it would just touch the vertex. So this would be the big triangle. So that would be C. Okay, so again, this is something you can figure out by looking at the top problem, how we redrew all three separately, but you don't have to redraw them every single time. You'll just use this to set up your proportion a little bit faster. And then our last case is actually just like number 3, but I just did a different leg this time. So I'm saying here is my altitude. Okay, so this is my altitude. So it's going to go in slots 2 and 3, or 1 and 4, as long as they're in opposite locations. What will I put in the other two positions in slots 1 and 4? Will it be A and B, A and C, or B and C? Mira? Good. The two triangles that it shares would be this one, which has B as a side, and then the other triangle that touches X would be the C. Okay? So you basically need to memorize these relationships. You really need to memorize the geometric mean, and then if you just remember it has to be the two parts that those triangles would share, those will go in the other slots. And then of course on the back we're actually going to be plugging numbers in here and then solving it. But these are your three kind of formula triangles to help you understand the concept. Alright, let's take a look at some examples then. So those of you that like highlighters, I usually highlight what the altitude is. Sometimes the altitude is a variable, sometimes it's a number. Okay? But this is my altitude. So remember, the altitude goes in slots 2 and 3. So X and X. And since this one is slicing the triangle into two similar triangles, the two triangles it would touch would be this one and this one. So we would put 4 and 5 in the two other slots. Those are the two triangles that would be similar that also share X as a side. So now we would cross multiply. Four times 5 is 20. Bring down our equal sign. Cross multiply the other direction. X times X gets us X squared, not 2X. And then just like the bell ringer, we're going to solve by square rooting both sides. Now when you square root X squared, these undo one another, just like adding 2 and subtracting 2 would undo and get back to 0. Squaring and square rooting undo one another to get me just X. Now the square root of 20, what can I reduce that to? What do I break it down into? Lexi? 4 and 5. Do we see why we had our little mini lesson yesterday? Square root of 4 then is 2. So X equals technically positive or negative 2 root 5. In these geometry triangle pictures, we will actually only take the final answer to be positive. And that's because you can't have a negative side length in a triangle. But in algebra, you want to make sure you include that plus or minus so you don't miss the answer. All right, the next one, which is my altitude in the picture? 8, 2X, or X? What is my altitude? Marquise? No. X is perpendicular, but it touches a vertex, but it doesn't touch the other side. Amira? 8. So an altitude, again, has to touch one of the 3 vertices and be perpendicular to the other side. So 8 would be my altitude or my geometric mean. So this time when I set up my proportion, 8 is going in slots 2 and 3. Sometimes it's a variable, sometimes it's a number. Okay, but we still set those to be equal because those will be corresponding parts. So again, look at the triangles that both of these touch. The other one touches the side with 2x. It also touches the side with x. And then we cross multiply. 2x times x is 2x squared equals 8 times 8 is 64. Now be careful, you cannot square root first. You have to isolate the x squared before you square root. Otherwise, you're then going to have to divide and rationalize. You don't want to have to do that. So the first thing you would do is undo multiplication with division to get x squared equals 32. Then you can square root. Katie, you going? We'll call for you like 2 seconds after you leave.
Thank you.
What would I break 32 into? What's the largest perfect square that goes in? Joey? 16. You can do 4 and 8, but then you'd have to break the 8 down into 4 and 2. So remember, if you pick the largest perfect square, it does make your life a little easier. So I will get, now the square root of 16 is 4. Every year some students are like, well, Mrs. Bennett, can I break the 4 down into a 2? No. It's now become an outside number. It's not reducible any further. So this would just be 4 root 2. Again, technically it's plus or minus, but since this is a geometry question and it's based on the length of a side, the length has to be positive. So 4 square roots of 2, 4 root 2. Okay, now, these were both where the altitude is going through the center of the triangle. The next two will have a mixture. Some of them are and some of them aren't. You'll also have more than one variable. So you're going to have to do 2 proportions to find each of them. Now, what is an equation, what is a theorem, I guess, that we know that can help us find the lengths in a right triangle? If you were to know, like this was 3 and this was 4, how can you figure out what the third side is? Justin? Pythagorean theorem, thank you. A squared plus b squared equals c squared. Okay, that can work in here too. So if you know 2 of the sides, which we don't know 2, we only know 1 of each of them. But if you were to know 2 sides, you can use the Pythagorean theorem in any of these right triangle problems to come up with the third side if you need to. All right, do you want to solve for x or for y first? It doesn't matter. Y. Okay, so y is an altitude. So whenever I set up my proportion, it will go in slots 2 and 3. What goes in the other slots? What triangles have side lengths that would be in the triangles that touch y? Marquise? 4 and 5. Okay, and then we're not going to end up getting the same answer as above, right? Y squared equals 20 square root. I'm just going to draw an arrow up here because we just reduced the square root of 20, 4 and 5, which gets us 2 root 5. It's done in highlighter. All right, now, x is also an altitude. Remember, the altitudes either go through the center to the hypotenuse, or they're actually legs. So this is also an altitude. So when I set up my proportion, x, since it's a geometric mean or an altitude, goes in slots 2 and 3. Now be careful when you pick the other numbers. It's not going to be 4 and 5 any longer. Remember, you're picking the triangles that touch x with a side. What would the 2 other numbers be? Amira?
4 and 9.
Good. 4 is in this triangle, and it touches that. And then the big triangle touches that. So you have to add 4 and 9 together, or 4 and 5 together, and get 9. Some students like to remember it's like the portion of the hypotenuse closest and the whole hypotenuse. Other students like to think about the triangles to figure out the numbers. Then we cross multiply. 36 equals x squared. We square root. Technically positive or negative 6, but again in geometry we only need the positive. So that's the perfect square for 6. See if you guys can try number 4 on your own. You may need to reduce some radicals. And then we'll look at the other. Who can tell me the second proportion they set up, which this is the harder one, Marquise?
4 over x equals x over 16.
Perfect. This is also an altitude, so it goes in slots 2 and 3. And again, you pick the triangles that would have this as a side. So 4 is a side, and then this would also show up in the large triangle, which is this whole side, which is 4 plus 12 to get 16. And then we cross multiply, we get x squared equals 64. And lucky for us, that's a perfect square. That's nice. Just 8. No reducing necessary. Okay. All right, let's take a look at number 5. 6 is the hardest. See if we get there. All right, so for this one, you have 2 altitudes. One of them would be 6. The other one would be what? What's the other altitude, Marquise? Y. Technically I have another one, but there's nothing on there, so like you can't use it. Now, there is a correct answer to which one should you do first. Okay, you would want to do the 6 first because it only has one variable associated, just the x. If you were to do y, you would also have x in your proportion and you can't find it. So you do have to solve for x first using the 6. So this is an altitude, it goes in slots 2 and 3. And we'll put in the 2 parts of the hypotenuse, 2 and x, because those are the 2 triangles that would be formed in similar. Now when you cross multiply this one, you're not going to have to square root. You're just going to get 2x equals 36. And you don't have to square, you just divide. You want to put that back in your picture because you're going to use that to find out what y is. Now for our next proportion, we're using y as the altitude. So it's going to go in slots 2 and 3. What numbers will I put in the other slots? Again, thinking about this as an altitude, think about the triangles that have this as a side of them. What would the, Kale? No. Justin? No. One of those is right, one of those is wrong. Marquise? 18 and 20. So you're always looking at the parts of the hypotenuse scale. So you don't want to use the 6. You want to think about which, so this triangle obviously touches that, and the part of the hypotenuse would be 18. And then also, the large triangle shares that side, which would be the whole thing, just 20. And then we'll cross multiply, and we'll get y squared equals 360. And we need to reduce this when we square root. What would we break that into? 36 and 10, very nice. Square root of 36 is 6, so 6 root 10 for y. Okay, we're not going to get to 6 in class, but I will do it on the video, so if anyone wants. Alright, for number 6, we didn't get to finish this one in class. What makes this one a little bit harder is that we actually don't know a lot of sides in this triangle. So we have an altitude y. And so if I were to set up the geometric mean right now, y would go in the 2 slots. But the problem is I would take, again, it would be this triangle, so x, and then I would take the whole side, which would be x plus 192, which that looks like really kind of hard to solve. If you do the same thing with this one, you're going to also get x's and y's. So one of my suggestions for this one is, if you notice in this triangle, we do have 2 of the 3 sides that we would know. We have the hypotenuse and we have a leg. So you can use your Pythagorean theorem. Okay, let this be A, this be B, and this be C. And then we would square each number, subtract them, and square root them. We'll get some pretty big numbers here. So 192 squared is 36,864. 240 squared will get us 57,600. And then we will subtract. We'll get 20,736, and then we'll square root that. And we'll get that A is 144, which means this side up here is 144. Okay, so that's going to make it a little bit easier to find out what x is, and then once we can find out what x is, we can find out what y is. So even though they didn't ask us to find this, it really, really helps us to find that missing piece. So this would be an altitude, 144. 144 would go in our geometric mean, slots 2 and 3. And then this breaks it into our 2 triangles here, so we would have x and 192. So we would cross multiply, and we'll get 192x equals, and we'll multiply 144 times 144, which will get me back to what I had under my square root here, 20,736, and then we'll divide that by 192. And we will get 108. Again, you want to put this back in your picture. Now the last thing we have to find out is what y is, and you have 2 options. You could do the Pythagorean theorem with the big triangle if you want to, but we can also use the geometric mean. So this is an altitude, y, so it will go in our geometric mean slots 2 and 3. Now again, when you're picking what goes in the other slots, it's pieces of the hypotenuse. It's going to be the triangle that touches y, which would be our 108 that we found in our last part. And then the other triangle that touches y would be the big triangle, which we have to figure out how long that side is by adding these 2 things together. So 108 plus 192 would get me that the entire side length is 300. And then we would cross multiply. It's going to get us a big number, 32,400. Equals y squared. And then let's check and see, maybe this is a big perfect square, which it is. Again, sometimes the Pythagorean theorem is really useful. If you know 2 of the 3 sides, you can figure out what that third one is, which then may make the problem a little bit easier.